This is Aaron Holmberg at Corvallis Middle School, and this worksheet is about training students to take a number that's written in standard form and rewrite that in expanded form with base 10 notation. This is a Common Core Standard 5 NBT A3A, which reads, read and write decimals to thousands using base 10 numerals, number names in expanded form, and it gives an example that is very much like this. Now, if all that's kind of mumbo-jumbo, the main thing to understand here is that Common Core Standards expect students to understand place value and number sense in deeper ways than they used to when I was a kid in the 1980s, for example. So that's really what's going on here, is we're teaching students how to take a number and stretch it out lengthwise, because when you see and understand a number's true value, then you can manipulate that number in a lot of other ways, and that's what we're after here. So this example across the top is kind of complex, like where we would want students to be able to get during this lesson. The only step that gets more complicated is if you have like a 0 in one of these places and what that does to some of these notations. So I'm just going to start real simple, and I'll try to move up to this in the course of this lesson. And here we go. So what's going to be hard for me is that I don't have a lot of room to share all this numbers, so I'm going to get this as best I can here and try to hold it in place. All right. So when students are in elementary school, they probably learn things like this, that if you have the number 3,421, they learn that expanded form pretty much says 3,000 plus 400 plus 20 plus 1 is expanded form, and that's not too difficult, and they're pretty used to that. But the ramp up here is that you're using base 10 notation, so you're always trying to show how a digit is the product of itself and a power of 10, and that's what's going on here. So if I were to take this one and rewrite this where we would be in 5th grade, it wouldn't look simply like this. It would begin to change into this expression. So I'll zoom in here a little bit to make this as big as I can. So the number 3,000 is not just 3,000, it's 3 times 1,000. 400 is 4 times 100. 20 is 2 times 10, and 1 is 1 times 1. So that is the way that number would be written, not merely in expanded form, but expanded form with base 10. The same number here, 3,421. Okay. So what becomes challenging then is right here for students when it begins to show decimals as well. And so what I'm going to do here for you is I'm going to try to show you that this notation doesn't contain like a decimal in it. Students need to see that the first part of this number right here is the whole number that sits in front of the decimal, and that where it has the fractions in the back end of it, that is where the numbers on the other side of the decimal would belong. And so if I can emphasize it here, it's as if the decimal is just sitting right here in this number, and the decimal in my example is in the same spot. And if I were to highlight the same way, here's the 8,356 is in the beginning, just like the 8,356 is sitting here. You can see the decimal is red, and the 274 thousandths is sitting right here at 274 thousandths in blue as well. So I'll try to give a few examples, and I'll try to move up here to where there's a 0 in something, and I'm going to do my best to have that so you can see this whole thing at once. And I'm sorry if it's a little bit small there for you. So let's just try a number that's 3,000. No, I'll change something. 8,000. Make that 3 to do it 8,262.7. And of course, in this class, we're training students to say that it's 8,262 and 7/10, not 0.7. But they really need to be able to say both and know that if somebody says 0.7, that means the same thing as 7/10. So this would be 8 times 1,000 plus 2 times 100 plus 6 times 10 plus 2 times 1. And then here's where it'd be nice to have the decimal in there, but it's not. It's just an and. We've got this. And 7 times 1/10. And the reason why you know that's the same thing as 0.7 here is that if you multiply this, and I'll just put this in Scratch up here, 7 times 1/10, put that over 1. 7 times 1 is 7/10, like that. 7/10 is the same thing as this. And of course, students should know coming out of 4th grade that if you take something like this, 10 into 7, 7 divided by 10, and put a decimal on there, that's where you get that 7, that 0.7 as the answer. So that's a way of tracking this idea all the way back through to what the decimal is right there. Again, sorry that's small. Okay, so we'll try another one here. I think I'm just going to use numbers that are not in the thousands just because they take a little less room over here. Maybe I'll do you one in the 10,000s just so you see it, but we might not get that far. So if I had 14,365 and 80 100s, how about this be the longest one I do? This would be 1 times 10,000. Now sometimes in class I'll let students shorten this up and I'll go 14 times 1,000, but to be